Hello everyone and welcome to Tutorials. Today we're going to be solving best time to buy and sell stock. The question prompt is as follows. You're given an array prices where prices at index I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So, in the question, the indices of the array represent the days when we can buy or sell stocks. We're going to try to buy at some index of the array and sell at a higher index. That is basically what is meant by choosing a different day in the future. Ultimately, the question wants us to return the maximum profit we can achieve from this transaction. If we cannot achieve any profit, we need to return 0. Let's take a look at some examples to better understand the question. In the first example, it is pretty obvious that the best strategy we can follow is to buy at this 1 and sell at this 6, which gives us a total maximum profit of 5. We cannot buy at this 7 and sell at this 1 because 7 precedes 1. What we want to do is buy at a lower index and sell at a higher index, as in the case of 1 and 6. In the second example, we cannot make any profit because it is impossible to buy at a lower price in a lower index and sell at a higher price at a higher index, since as we go to the right, the values of the array decrease. This is because we have a strictly decreasing array. We can generalize this to monotonically decreasing arrays, since the best strategy we can follow would be to buy and sell at the same price, giving us a net profit of 0. So as a result, in this case, we need to return 0 because we cannot make any profit. As for our approach to solving this problem, we need to realize that at each time we have two choices. We can either buy or sell on any given day. We cannot do both because we're restricted by the question of not doing so. Then you might ask, how are we going to decide which action to take on any day? As you can guess, because we want to maximize profit, we're going to decide whether to buy or sell according to the value of the stock. In order to do so, we need to buy at a lower price and sell at a higher price. Thus, if the value of the stock at the current index is lower than the value of the stock that has the lowest value up until to that day, we're going to decide to buy on that day. The idea in that choice is that if we minimize our buying value, we're going to make a higher profit no matter what the future value is. It just needs to be higher. If we don't encounter a lower value at the current index, then we're going to decide to sell and calculate the potential profit we can get and compare it to the max profit we have obtained until that point, and update the max profit value if we have a higher profit at the current index. Verbally, this approach might be confusing, but you will get the hang of it by seeing it in action on an example. We're going to take a look at how the algorithm works on the first example. As I've hinted in the conceptual overview of the algorithm, we're going to hold two different variables. The first one is min price, and the second one is max profit. We will initialize our min value to the first element of the array, which is 7 in this case, and the max profit to negative infinity because we haven't made any transaction just yet. And then we're going to start iterating from the first index, which has the value 1 in our example. As we can see, 1 is less than 7, so we're going to be deciding to buy at 1. Thus, we need to update our min price to 1. And then we're going to move on to 5 and then see that 5 is greater than our min price. In this case, we need to make a sell decision and calculate our potential profit. We're going to be calculating the potential profit by subtracting the min price from the value of the stock at the current day, which is 5. 5 minus 1 yields 4, which is greater than our current max profit, so we're going to update it to 4. And then we're going to move on to 3 and see that 3 is greater than our min price. Thus, we're going to reiterate what we have done in the last step of the algorithm and subtract our min price of 1 from 3 and obtain 2. Since 2 is less than our max profit, we're not going to update our max profit and move on. Then we're going to encounter 6 and see that 6 is greater than our min price and subtract our min price of 1 from 6 and obtain 5. Since 5 is greater than our current max profit, we're going to update our max profit to 5. And then we're going to move on to 4 and see that 4 is also greater than our min price value and subtract 1 from 4 and obtain 3. Since 3 is not greater than max profit, we're not going to update it. And now, since we have come to the end of the array, we can return our max profit value of 5, which is actually the answer of the first example. On a final note, if we were to run our algorithm on the second example, we would be constantly updating our min price value on each iteration because it's a monotonically decreasing array. And we wouldn't update our max profit value, which will be remain constant at negative infinity at the end of the algorithm. In that case, we need to return 0, not negative infinity. We're going to be handle that case in our coding solution. Now, let's talk about the time and space complexity of our algorithm. The time complexity of this approach is O of n, where n is the length of the prices array. The space complexity is O of 1. This is because we're performing a single iteration over the array and using only a constant amount of extra variables. Now we can move on to the coding solution. The first thing I'm going to be doing is initialize our min price and max profit variables. And then we're going to start iterating over the array from the first index. Then we'll get the next price value from the current index and compare the next price to our min price. If our next price is less than our min price, we're going to update our min price and continue our iteration. So what we're essentially doing in this case is buying at a lower price. In the else case, we're going to be selling at the current price and get our max potential profit. So I will try to update our max profit value. This will enable us to get the maximum of the current value of max profit or trying to sell at the current price. If selling at the current price yields a greater profit, we're going to be updating max profit accordingly. If it's not, we're going to be keeping the value of the max profit. Thus, when we break out of this for loop, we're going to achieve the maximum profit possible from the prices array. And finally, I'm going to return max profit if max profit is not negative infinity. If it is negative infinity, we want to return 0 as we have seen in the second example. And that's it. Let's submit our code. As you can see, our solution is correct and pretty efficient. I hope you found this video helpful. And if you did so, please like and subscribe. I really appreciate your support to my channel. And I'll see you in the next one.